Hi students, welcome to this new video on tutorial 3, where together we will solve question 1 and question 2. Now, in the first question, you are asked to solve the homogeneous system Ax equals to 0, where A is given as this. Now, as a solution, right, we are instructed to use the Gauss reduction method. So we have that B is 0, 0, 0. So the first step to do is to write the augmented matrix like this: 0, minus 4, 1, 0, minus 4, 1, 0, 0, 0. So what do I need? Um, I need to find the leading entries, the leading one. So I realize that I can do R2 equals to R2 minus R1, right? So that I can have some 0 here and some 0 here. And I do R3 equals to um, R3 minus R1, so that I also have some 0 here and 0 here. So this will lead to 0 minus 4, 1, 0, 0, 0, 0, 0, 0, dot, 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 0, 0, 0. Okay, from these, um, we can clearly see that if we can also write, say, we'll do that R1 divided by minus 4, right? Then we will obtain 0, 1, minus 1 over 4, 0, 0, 0, 0, 0, 0, 0, 0, 0. Right. So from here, you can see that you have, yes, you have this pivot. You have x1, you have x, x2, you have x3. So you have that you have one pivot, which is variable x2, and you have two free variables, right? Which are x1 and x3. So these are free variables, and x2 is fixed variables. So from the first equation, from the first row, right, we have that x2 minus 1/4 x3 equals to 0. X1 and x3 are free variables, so we have x1 equals to s and x3 equals to t. So it means that this equation will lead to x2 equal to 1 over 4 x3, which is 1 over 4 t. Right. So if we therefore write our x as x1, x2, x3, we have that x1 is s and x2 is 1 over 4 t and s3 is t. So we have s 1, 0, 0 plus t 0, 1 over 4, 1. Right? So we we see that the solution therefore of the homogeneous system will be s 1, 0, 0 plus t 0, 1 over 4, 1, where t and s are scalar belonging to R. Okay, so we have done the first question. You saw how easy it was. Now, let's look at the second question. Question 2, right? You have a set S given as 100 and 101, right? And the question is, show that S generate, so that S generate the XZ plane in R3. Now, how do you answer such a question? How do you attempt to answer such a question? Now, the first step here, basically from what is given, the first step that you can do here is to check if the vectors 1, 0, 0 and 101 are in the XZ plane. That's the first thing. That is, you check if the y coordinate is 0. So from from the first vector here, you can see that y is 0. From the second, you can see that y is also 0. So we can conclude that the vector 1, 0, 0 and 1, 0, 1 are in the XZ plane. Okay, now the second step to follow, because remember you are trying to answer the question to show that S generates this plane in R3. Now, what you have to do now here is to apply the definition of a generating set, right? Now, a space generated by S, right, is all the linear combination of S. Let me write it down. A space generated by S consists of all the linear combination of the vectors of S, right? So it means that we need to find an arbitrary vector, right, written as S0T. Remember, you said that there should be no, the coordinate on Y should be 0. That's why we write it this way, right? And this arbitrary vector should be written as a linear combination of the vector of S, alpha 100 and beta 1001. Now we we need to we need to find the alpha and beta, right? Such that we need to find alpha and beta such that this writing is possible. S0T equal to alpha 100 plus beta 101, right? So, and from this equation, we can simply see that S equals to S equals to alpha plus beta and T, right? T equals to beta. So anytime we have S equals to alpha plus beta and T equals to beta, this vector will be written as a combination of the vector of S. And this vector belongs to the plane xz because the y component is 0. Therefore, we have proven that S generates the xz plane in R3. I hope this video helps you and we enable you to solve more exercises in this section of the lecture. Thank you.